Hello guys, welcome to another daily Leetcode challenge. Today we'll be solving question 242, valid anagram. Anagram, as it will probably explain later, it will, so never mind. Let's read the description. Given two strings s and t, return true if t is an anagram of s and false otherwise. So now what is an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So this is critical. The one property of what makes two strings anagrams is all the letters have to be present. The second property is that they have to be present in the correct count or amount. So if A appears twice in string S, A has to appear exactly twice in string T. And so there are some examples of anagrams where some letters are rearranged and the output is true, and then we have rat and car. R does exist, but T and C don't overlap. So, and what I really mean is T doesn't exist in this string and C doesn't exist in this string. So the answer is false. How do we come up with the solution? Well, in my opinion, it's pretty simple. We have to build up some intermediate data structure that will have the ability to track these two properties. And the properties, again, the occurrence of strings and the amount of the occurrence of characters and the count of those characters. And the first thing that comes to mind for me is a dictionary. Keys can be characters, values can be the occurrences. Let's make this dictionary. I'm going to make it a default dictionary with type int, such that for C and S, so when I traverse all characters in S, I'm going to basically just make sure that C value gets incremented by 1. What I should be left with is a dictionary where all the characters that are present in occurrences as keys, and their occurrence count is the value. What's left to do is probably do the same thing, but for T, except this time I'm going to be not adding but subtracting. And what that would look like is this. Minus. Now, one more thing, I want to check if not occurrence of C, I want to actually completely delete this element from the dictionary. Otherwise, it's just going to be 0. And then I want to return len of, let's see, occurrence, right? I should be left with an empty dictionary. And let's see if this works. There's probably other ways to do this. I don't have to do keys at all. Let me see if this works. Did I do something wrong? Del occurrence C, if not. Wait a second. Let me print this. I'm a bit confused. I have an empty dictionary output true, so I want to make sure that my len is equal to 0. Oh, I'm sorry. Len has to be equal to 0. If len is equal to 0, then return true. Otherwise, false. Mix up on the last bit. The logic here is correct though. So what I was doing there is just checking that my occurrence dictionary, that intermediate data structure that keeps track of those two properties, is completely empty by the end of the algorithm, which makes it an anagram. Let's see some other solutions. I'm sure that there's some quicker ones. Oh, and they're using the I mean, I guess it's time that I can start using some of these data structures that are part of Python. A counter is actually exactly what we did here. So if we were to do something like this, let's say s counter, and I believe t counter, we could just return s counter equal to t count. S counter is equal to t counter. We could do the same, but obviously, wait, what did I do here? Sorry, I've completely, why did I delete that? Why did I delete the code that was populating, the, dun dun. Let's do this. Let's do this for C and S. I want to increment counter, and then I want to do the same thing with T and fix this guy. Let's see if this works. Should be identical to what we saw before without using the data structure there. And yeah, it's a bit quicker, but uses a bit more memory. So it's up to you. I would suggest probably even just going with the built-in data structure here. All right, let's end it here. Thanks for watching. This was a quick one. Like and subscribe, and I'll see you tomorrow.